Okay, apologies for the sort of leaning. I've switched cameras, so I have to lean around to click my slides on. I'm Tanya. I'm a PhD researcher looking at curriculum design for 11-year-olds, but I also develop and teach short courses to university students who've moved away from formal computing and are largely using computers for things like computer-aided design. Click at the right button. I've been working with the School of Art and Design at my local university to develop courses that integrate into the second year of study. Through interaction design and rapid prototyping, they develop an interactive piece, whether it's something small that you can hold in your hand or a full-blown interactive display. So when these students were in year 9, the microbit didn't exist. And by the time they were choosing their options at year 9, the microbit was just crawling out of Make It Digital. And their computing education was learning Word and Excel, although they did have the PlayStation 4, so win some, lose some. The students have limited skills in coding, but they're using advanced software for their courses, like Photoshop and Illustrator. And in the case of the graphics students, they're making their own animations. But it's a question of how can you build on that when you only have 8 weeks to deliver the module? I'm getting feedback from Pauline's microphone there, sorry. Physical computing is ideal, as its very definition is creatively designing tangible interactive objects, and that fits slap bang in the middle of pretty much every art and design course. So why don't we use it more? It's because we have a terrible habit of siloing computing education into its own subject, and then we lose, like so many people, sorry, I've lost my clicky button along the way, because we haven't made it an integral part of the curriculum. Now, traditionally, any university level physical computing was done with Arduino with mixed results. Sorry, not bad-mouthing them, but I am saying the microbit is better because the initial push with the microbit was towards like 11-year-olds, but you can see that it's been used with loads of different age groups to great effect. One of the things you've got to think about with university students is they don't want to be seen to be doing something unsophisticated. But equally, you need something that allows them to start exploring straight away. So emphasizing to them it starts with block coding, but it can quickly develop into something else was important. And another thing they needed to see straight off was applications for it in their practice. So one of the first exercises I do with them is using conductive paint and their own designs, and they make a sort of touch sensitive. So basically they touch their picture and it lights up the microbit screen. Questions then start coming at you. What can it do? What can I make it do? How do I control this? And this is where it's sort of encyclopedic knowledge of the microbit comes in. The learning happens when they're engaged in making something tangible. And this is where I think it differs from a school or a code club environment, because rather than focusing on the various bells and whistles of the microbit itself, they need to work backwards from what they want their end project to be. And it becomes a powerful tool for rapid prototyping, which is a technique used in industry. I've lost my button. There we go. Rather than teach them as a lecture, I've found that they prefer exploratory sessions. So I give them a microbit that's doing something and a copy of the code and no instructions. And they figure it out. They look for meaning in the code, and then that generates more questions. And we figured out what this bit does, but what's this bit here for? And you'll be pleased to know that Chuck a Duck holds as much wow factor with 20-year-olds as it does with curious 11-year-olds. In 5 minutes, it's really difficult to get across the differences in teaching methods. But whereas with a school or a code club, you're aiming at students, starting with some code and building a use for it, at university, it's much more focused on starting with their creative project they use and trying to figure out how you'd use the microbit in it. Ideally, I'd like to see these students become volunteers and mentors to school-age children, because for this cohort of students, they've not previously seen coding have a place in what they do. And there's a real opportunity to use artists, designers, fabricators to help build coding capital from an early age. And another powerful way of developing the students' confidence in using the microbit is to get them to share what they're doing with each other across disciplines. So you get students who've used it for gathering data and students who've used it for lighting effects, and then they'll start advising each other on how their techniques can work together. And it's really interesting to listen in on the language that they use as well. It's a lot more natural language, and there seems to be a lot more ownership of their own terms. For example, a group of mine will never refer to pins. They won't use input output. They'll say things like, I've got my breathing on 1, so that's going to set off my starlights on 2. And the microbit's seen as a sort of joiner-upper of humans and things for humans rather than a cold input-output device. Am I ruining coding terms and technical language for them? I don't think so. If they want to, they'll go off and fill in those gaps themselves. And I've been really happy to see that they're now bringing in like electronic items that they've bought and pulled apart to see what they can combine with the microbit. So one of my students has a greetings card voice recorder and is using that to trigger spoken reassurances. 1 minute. And they're using the microbit as a tool for their creativity. And the form, this one is really interesting. It was a process the student said, can I draw with a microbit? So we hooked it up to Scratch, and then she had a 2D drawing, and then she explored serial data and exported it out into Excel, cleaned up the data, graphed the movement, and finally printed it out in 3D. So she has a sculpture of her dance. What gets me is the projects they've made, and after all having the same initial instruction, they're so wildly different, from a brooch to a sculpture to a room full of touch-sensitive glowing jellyfish. And this makes me feel like the microbit is a brilliant starting step to bringing those who we lost along the way back towards a fulfilling experience with coding. And hopefully that's my 5 minutes done.